Hello everyone, once again welcome to MPLS series. Guys, in this video of MPLS we are going to talk about IPv6 over MPLS. How to configure IPv6 over IPv4 tunnel on CE routers. See guys, in this scenario, first of all let me make you familiar with this topology. In this topology, as you can see, we have only one customer A. This is side 1 of customer A and this is side 2 of customer A. In side 1 and side 2 of customer A, we are using IPv6 addressing. Here you can see customer A side 1 is using IPv6 address. Here also you can see in side 2 of customer A, we are using IPv6 address. And in ISP, in provider network, we are using IPv4 addressing. And service provider is not going to update their network from IPv4 to IPv6. So how we can exchange or make communication between IPv6 network over MPLS. IPv6 network over MPLS. Solution is tunneling. We can create IPv6 tunnel over MPLS. See, between router 4 and router 5, we will create one IPv6 over IPv4 tunnel, right? And through that tunnel, we will exchange IPv6 prefixes between customer A side 1 and side 2. Getting my point what I am saying? I will create one IPv6 tunnel between router 4 and router 5, which are C routers, customer A's router, and through that tunnel we will exchange IPv6 address. And you will see, first we will discuss the configuration part. After that I will show you the packet flow also, that how customer A side 1 is going to communicate with customer A side 2. Okay, first of all, see the configuration, how we are going to configure the scenario. Okay, and tunneling configuration is similar like GRE tunnel. If you know GRE tunnel configuration, same tunneling we are going to configure between router 4 and router number 5, between C routers. Okay, and on the tunnel I will use this IPv6 address. On the tunnel interface we will use IPv6 address from this subnet, and here you can see this is IPv6 subnet we are using in side 1 of customer A, and this is IPv6 address that we are using in side 2 of customer A. I am going to configure this scenario from the scratch. Even I have not configured the IP addresses on router, so I will configure everything like IP address, OSPF in service provider network, BGP, MPLS, everything. Okay, so first let me configure provider network, and then we will configure customer edge router like C routers, router number 4 and router number 5. First of all, here you can see I have console of all routers. Let me configure IP address on router number 1, router 1 interface F0/0. I am going to configure IP address on fast Ethernet 0/0 and loopback interface, because fast Ethernet 1/0 we will configure fast Ethernet 1/0 as a member of VRF, right? So we will configure IP address on this interface later. After configuring VRF, maybe we will configure VRF A1 or any VRF we can create here, and this interface will be the member of that VRF, because this is router 1 is my PE router, and router 3 is also PE router, and router 2 is provider router. So on router number 2 I will configure only OSPF. On router number 1 and router number 3 we will configure OSPF and BGP. Okay, so IP address on fast Ethernet 0/0 say no shut, and IP address is 12 dot no shutdown, and IP address between router 1 and router 2 I am going to use 12 network 12.1.1.1 255.255.255.0. You can use any IP address. Then interface loopback 1, and IP address is 1.1.1.1 255.255.255.0. and then I am going to define MPLS label range 100 to 199 here. Okay, this is the configuration only on router number 1 for now. Let me configure IP on router number 2 and MPLS label range. Interface F0/0 say no shut, and IP address is 12.1.1.2 255.255.255.0. Then exit. Interface fast Ethernet 1/0. Here also say no shut, and IP address is 23.1.1.2.255.255.255.0. Between router 2 and router 3 I am using 23 network. Here I don't need to create loopback, so I am not going to configure loopback here on router number 2. Let me define MPLS label range 200 to 299 here. Okay, after that router number 3, config T, interface F0/0, interface F0/0, say no shutdown, and IP address 23.1.1.3.255.255.255.0, exit interface loopback 1, and here I am going to say IP address 3.3.3.3 255.255.255.255. Done. I have configured the loopback and the IP address on physical interface like fast Ethernet 0/0. Then MPLS label range is 300 to 399. Okay, IP configuration and MPLS label range configuration is done on router number 1, 2, and 3. The next configuration is OSPF. Let me configure OSPF and MPLS on router number 1. Router OSPF 1, and say router ID is 1.1.1.1, and then I am going to advertise network 12.1.1.1 0.0.0 area 0, and the network 1.1.1.1 0.0.0 area 0. Okay, and after that MPLS LDP auto config. Okay, done. This is the configuration of router number 1. Let me configure R2 router OSPF 1, and say router ID 2.2.2.2, and then network 12.1.1.2 0.0.0 area 0, and network 23.1.23.1.1.2 0.0.0 area 0. Soon OSPF neighborship will come up between router 1 and router 2, and then MPLS LDP auto config. Wait for, sorry, here this is the network 12.1. Yeah, fine, correct. OSPF neighbor will come up, do ping and 12.1.1.1. yeah, there is reachability, so OSPF neighborship will come up here. For the faster convergence we can change network type also, so IP OSPF neighbor, yes, 1.1.1 is the neighbor. Okay, and you can see the LDP neighbor also 1.1.1. okay, now let me configure R3 on router number 3, router OSPF 1, and say network router ID first, router ID let's say 3.3.3.3, and then network 23.1.1.3 0.0.0.0 area 0, and network 3.3.3.3 0.0.0 area 0. Now here we have OSPF neighborship. Soon LDP neighborship will also come up after running command MPLS LDP auto config. Okay, LDP neighborship will also come up, you can see here. And now I am going to check the connectivity between 3.3.3 and 1.1.1. so let me ping 1.1.1 and source is 3.3.3.3. so yes, there is reachability. Now we can configure BGP between router 1 and router 3. Before that you should verify everything like OSPF configuration, so IP OSPF neighbor is fine, and so MPLS LDP neighbor, so router 2 is LDP neighbor, and on router number 2 so MPLS LDP neighbor. So yes, router 2, router 1 and router 3 is neighbor. Okay, now finally I am going to configure BGP on router number 1. so let me configure BGP AS number 65,000, router BGP 65,000 here, and say neighbor 3.3.3.3, remote AS is 65,000, IBGP neighbor, and then neighbor 3.3.3.3, update source loopback 1, and address family VPN v4 VPN v4 unicast, and then neighbor 3.3.3.3 activate. Okay, this is the configuration of BGP on router number 1. let me configure BGP on router number 3. so config T router BGP 65,000, and here I am going to say neighbor 1.1.1, and remote AS is again 65,000, and then neighbor 1.1.1.1, update source loopback 1, and then address family VPN v4, and neighbor 1.1.1.1 activate. This is thus exactly same configuration of previous video. We discussed this configuration many time in previous video, so hope you are mastered in this type of configuration, like configuring MPLS, BGP and OSPF in service provider network, or configuring service provider network, right? So now you can see we have BGP neighborship between 1.1.1 and 3.3.3. We can verify it also. So BGP VPN v4 unicast all and summary. So you can see 1.1.1 is neighbor of router number 3. Okay, so till now I have configured service provider network. Now finally we are going to configure VRF on router number 1 and router number 3. So first of all, let me take you to R1, and here I am going to say IP VRF, and let me create a VRF, let's say customer A, and here I am going to define RD value, let's say 1:1, and route target value both, let's say 100:100. Okay, exit, and then interface fast Ethernet 1/0 IP VRF forwarding customer A. And then I am going to say here IP address between router 1 and router 4. I will use 14 network, 14.1.1.1, 255.255.255.0, and say no shutdown. And now if you will check routing table of VRF customer A, so IP route VRF customer A, you can see 14 network is there. Okay, now in the same way I am going to create one VRF on router number 5 also, sorry, on router number 3 also, not 5. Here I'm going to create same VRF. You can create different VRF also. We don't, we can configure same or different, it doesn't matter. So IP VRF here also I am going to say customer A, because on router number 3 and on router number 1 I am creating VRF for same customer, so that's why I have used same name, and same RD value also I am going to use, and same route target value also I am going to use 100:100. route target value both 100:100. After that, interface F1/0 and IP VRF forwarding customer A, and then IP address between router 3 and router 5 I am using, let's say 35 network, 35.1.1.3 is the IP address of this interface, 255.255.255.0. okay, and say no shut finally. Now if you will here check, so IP route VRF customer A, you can see 35 network is there in the VRF routing table. Okay guys, now here, so BGP VPN v4 unicast all. In BGP table we don't have any prefix on router number 1 and on router number 3, because router 4 have not advertised any network. See, before configuring tunnel, first of all I am going to configure one loopback address on router number 4 and on router number 5, and on loopback we will configure IPv4 address. You will understand why we need IPv4 loopback on router number 4 and on router number 5. okay, that loopback will become tunnel source IP address. First of all, let me configure that. Let me take you to router number 4 and let me configure IP first on interface 0/0 interface, say no shutdown, and IP address over here is 14.1.1.4, 255.255.255.0. between router 1 and router 4 I am using 14 network, so here IP address is 14.1.1.4. after that I am going to create one loopback here, interface loopback, let's say 1, and IP address is 4.4.4.4, 255.255.255.255. I have created this loopback interface on router number 4. In the same way I will create one loopback on router number 5 also. So let me first configure IP address on F0/0 interface, say no shut, and then IP address 35.1.1.5, 255.255.255.0. okay, and then one loopback interface loopback 1, and IP address is, let's say 5.5.5, 255.255.255.255. Okay, after that we need to configure BGP neighborship between P to C. As you already know, here we need to configure BGP neighborship, right? Okay, so let me configure BGP neighbor first. On router number 4 I am going to configure BGP router. BGP AS number is 100 and say neighbor is 14.1.1.1 and remote AS of this neighbor is 65,000. And then I am going to advertise the loopback which I have just created 4.4.4 and mask is 255.255.255.255. I have advertised this network. And now on router number 1, if you will check BGP table, so in BGP table there will be one network 4.4.4.4. So BGP VPN v4 unicast all you can see here it have not received. Just wait for some time. Okay, on this router also actually we need to configure BGP, right? On router number 1 for VRF for customer, for CE router, like for router number 4 router BGP 65,000 and then neighbor 14.1.1.4 say remote AS is. Okay, here we will not run this command. In address family IPv4 unicast VRF customer A. For this customer, for this VRF I am going to configure BGP neighbor 14.1.1.4 and remote AS is 100. And then I am going to say neighbor 14.1.1.4 AS override. Okay, and now you can see BGP neighborship. I think let me check BGP table. So BGP VPN v4 unicast all, yes, it have received this network 4.4.4 in BGP table, right? Okay, okay, and so summary. So here you can see now router 1 have two BGP session, one with 3.3.3 and it have not received any prefix from 3.3.3. it have received one prefix from this neighbor 14.1.1.4. okay, in the same way I am going to configure this side 2 of customer A. Let me configure BGP, I think so, on router number 5 first router BGP 100 and then I am going to say neighbor 35.1.1.3 35.1.1.3 and remote AS is 65,000. And then I will advertise loopback IP address, that is 5.5.5.5. mask is 255.255.255.255. done. After that on router number 3 also we need to configure BGP for VRF router BGP 65,000 and then say address family IPv4 unicast VRF customer A and then say neighbor 35.1.1.5 and remote AS is 100 and then neighbor 35.1.1.5 ES override, right? Yes, override. And now you can see we have BGP neighborship. And here if you will check BGP table, so BGP VPN v4 unicast all, so you can see it have received 5.5.5 from this neighbor and 4.4.4 from 1.1.1 from. Okay, so till now whatever things we have configured you already know this, right? And on router number 1 also you can check now BGP table. In the BGP table, yes, 4.4.4 and 5.5.5 is there. And now finally I am going to check the reachability from customer to customer, okay, from router 4 to router number 5, that is it router 4 is able to ping router 5 or not. 5.5.5 and source 4.4.4.4. so let me check the reachability. No, there is no reachability. Okay, first of all we have to troubleshoot it. What is the problem here? On router number 4, so IP route in the routing table, yes, it have received 5.5.5 through BGP. And on router number 5, let me check, so IP route it have also received 4.4.4. so we don't have a problem in control plane, right? Both router have received prefixes, both CE routers have received prefix of other side. Then what is problem? Let me check MPLS on router number 1, so MPLS interface, So MPLS is enabled on fast Ethernet 0/0, that is fine. And so MPLS interface, here also MPLS is enabled on both interface fast Ethernet 0/0 and 0/1, and on router number 3. So MPLS interface, so here MPLS is enabled on fast Ethernet 0/0 on router number 3, and so MPLS LDP neighbor fast Ethernet 0/0 neighbor is 23.1.1.2. So ping should work. Let me follow the packet. What is happening? Why ping is not working? When I am pinging, let me write here. When I am pinging 5.5.5.5 from source 4.4.4.4 with source 4.4.4.4, router 4 will check their routing table. In their routing table, one route is available towards router number 1. Here you can see on router number 4 there is one route, so IP route available right towards router number 1 to 245.5.5. 14.1.1.1 is the next hop. It will forward the traffic to router number 1. Router 1 will receive the traffic on fast Ethernet 1/0, so it will check routing table of VRF customer A, because fast Ethernet 1/0 is member of this VRF. And here you can see 5.5.5 is available through 3.3.3.3, right, through 3.3.3.3. And this is, it will check which table it is reachable via 5.5. So IP route VRF customer A. In this VRF routing table, 5.5.5 is reachable through 3.3.3, and this is VPN v4 prefix. It in BGP table, it have received, means router 1 have learned 5.5.5 through BGP through 3.3.3. This is this was VPN v4 prefix, right? So as you know, there will be one labeled with this prefix. So how we can check that label? So BGP VPN v4 unicast all, and we can say 5.5.5.5 255.255.255.255. So yes, label is 302. So it will add one label, router 1 will add one label, inner label, that will be 302, and there will be one outer label to forward traffic to 3.3.3. So it will check, so IP, let's say SAF, and we can check SAF table for 3.3.3/32. label is 201. It will add outer label 201. After that it will forward the traffic to router number 2, because here you can see exit interface is fast Ethernet 0/0. next hop is 12.1.1.2, 12.1.1.2, right? It will check actually this table. So router 2 will check MPLS table because it is receiving labeled packet. So when router 2 will receive labeled packet, it will check so MPLS forwarding table. In forwarding table, it will compare outer label. Outer label is 201. When outer label is 201, it will pop the label, means it will remove. Pop the label means remove the outer label, top label. So it will remove this top label, and then it will forward the traffic to router number 3. Will forward the traffic to 3.3.3, and next hop is 23.1.1.3, right? From this interface it will forward the traffic. When router 3 will receive it, what router 3 will do? Router 3 is going to check their MPLS forwarding table, because this is labeled packet, still there is one label, so MPLS forwarding. And what is the label? Label number is 302. So if label is 302, remove the label, no label, outgoing label is no label, and forward the traffic to 5.5.5.5 from interface fast Ethernet 1/0. From fast Ethernet 1/0, it will remove the label, and then it will forward the traffic to router number 5. And let me check one more thing here. So run interface loopback 1. Here what is the IP address on loopback and on router number 1 also? So run interface loopback 1, here IP address. Okay, so on here we have problem. Actually this IP address should be with /32, not /24. We already discussed this in previous video, so let me correct it also. Interface loopback 1, and then IP address is 1.1.1.1 255.255.255.255, right? and after that router 3 will forward it to router number 5. So everything is fine. Here it should work, ping should work. Let me check again the connectivity. It ping was not working because of loopback interface IP address. Now I am going to ping from router 4 to router number 5, ping 5.5.5 source 4.4.4, and now you can see ping is working, right? So there is reachability. Okay, now I am going to create tunnel between router 4 and router number 5, right? GRE tunnel. So on router number 4 I am going to run one command, interface tunnel, let's say tunnel number 1, then tunnel source. Tunnel source is my loopback interface. Tunnel source means 4.4.4. tunnel source we can say loopback 1, and loopback 1 means this tunnel interface 4.4.4 and 5.5.5 is reachable with each other, as you already know, right? So your tunnel source is loopback 1, and tunnel destination is going to become 5.5.5.5. tunnel destination is 5.5.5. so whenever it will encapsulate GRE header, in the outer header source will be 4.4.4 and destination will be 5.5.5, because tunnel source you have defined 4.4.4 and tunnel destination you have defined 5.5.5. okay, so on router number 4 I have defined the tunnel source, tunnel destination, and then I am going to configure one IPv6 address here. As I told you that I will create IPv6 tunnel over IPv4. Okay, so here IP address is 200.2.0.0.1 colon db8 colon 4 colon 5 colon 4 slash 64. This is the IP address which we are using for tunnel, right? IPv6 address. Here I have defined the IPv6 address. Where, what is the wrong? Okay, here double colon is missing, double colon. Okay, I have defined the IP address on tunnel 6 tunnel interface. In the same way I am going to create one tunnel on router number 5 also. So let me take you to R5. Here also interface tunnel 1, and then tunnel source is loopback 1, tunnel source is 5.5.5.5, and tunnel destination is 4.4.4.4, and then IPv6 address. Here I am going to define IPv6 address, that is 2001 colon db8 colon 4 colon 5 double colon 5, let's say here, and slash 64. Done. Now I am going to check that tunnel to tunnel reachability is there or not. Let me first check the connectivity between tunnel to tunnel. From router number 4 I am going to ping the tunnel IP address, other side tunnel IP address, that is 201 colon db8 colon 4 colon 5 double colon 5, and say source is similar like this. So let me copy it, and source is this one 4. Let me check. Yes, you can see there is reachability, means tunnel to tunnel reachability is there. Now through this tunnel interface we can exchange IPv6 prefixes, right? We can configure static routing or we can configure routing protocol. Let me configure one static routing now. On router number 4 I am going to configure this network. Let me copy this network, copy, and here on router number 4 I am going to say IPv6 route, and then this IP address, and after that next hop IP address or exit interface. We can say tunnel 1 as a exit interface, tunnel 1, let's say. Okay, and then we need to configure one static route on router number 5 also, this IP address. Let me copy it, and here on router number 5 I am going to paste this, sorry, IPv6 route this, and tunnel 1. And now if you will check routing table, so IPv6 route, so you can see there is one static route, right? There is one static route connected on tunnel interface. And if you will check the connectivity now, let me check connectivity, end-to-end connectivity, ping 2001 colon db8 colon double colon actually 5, and say source is 2001 colon db8 double colon 4. So 2001 colon db8 double colon 4 and 2001 colon, this is no valid source address. 2001 colon db8 double colon 4 source is, actually we have not defined the IPv6 address on loopback interface, right? We have configured the static route, but we have not configured this IP address on customer edge router. So on router number 4, I am going to create one loopback, let's say interface loopback 10, and on this loopback interface I am going to say IPv6 address 2001 colon db8 double colon 4 slash 20 128, and on router number 5 also I am going to create one loopback, let's say interface loopback 10, and then IPv6 address 2001 colon db8 double colon 5 slash 128. IPv6 address done. And now I am going to check connectivity. So from router number 4 I'm going to use this command, and now you can see ping is working. So this is the static method, and now you know how ping is working. When you will ping this IP address, let me make you understand the packet flow also. When I am pinging this IP address 2001 colon db8 double colon 5 from the source of this 2001 colon db8 double colon 4, right? Source is this one and destination is this one. When I will ping, first of all router 4 is going to check their routing table. So router 4 will check IPv6 routing table. So v6 route, in their IPv6 routing table, one route is available for destination network for 2001 colon db8 double colon 5. You can see here one static route is available, and exit interface for this destination is tunnel 1, right? Tunnel 1, and on tunnel 1, if exit interface is tunnel interface, it is going to add GRE header here. It will add GRE header, and after that it will add IP header. In that IP header, source will be the tunnel source IP address 4.4.4.4, and destination IP will be 5.5.5.5 tunnel destination IP address, and then it will add layer 2 information, and after that it will forward the traffic to router number 1. Okay, so this will be my actual packet. Router 4 is going to forward this packet to router number 4, because to forward packet to 5.5.5, so IP route to forward packet to 5.5.5, we need to forward traffic to router number 1. When router 1 will receive this packet, it is not going to open IPv6 header, right? It is not going to open GRE header. It will open only upper header. In upper header, source IP is 4.4.4 and destination IP is 5.5.5. so forwarding will be, you know, exactly similar like previous video, or the MPLS label will be there. If we will capture the packet, let's say here between router 1 and router 2, I am going to capture the packet. If you will see the capturing, so rest thing will be exactly same. Again I am going to ping, let's say from router number 4 I am going to ping this IP address, and now you can see the ICMP request message. If I will open any ICMP request message here, you can see this is actual ICMP message, ICMP version 6 message. After that, outer IP header, in the outer IP, inner IP header, in the inner IP header, source is IPv6 address and destination is IPv6 address. After that, GRE header, and then outer IP header. In outer IP header, source is 4.4.4 and destination is 5.5.5, and after that there is 2 MPLS label. There is 2 MPLS label exactly like previous video. Okay, so one label is 201 on router number 1, you can check. So MPLS forwarding table. To forward traffic to 4.4.4, to forward traffic to 3.3.3, outgoing label is 201. Outgoing label is 201. And after that there is one inner label, that is the label of VPN prefix. So BGP, VPN v4, unicast all, and 5.5.5.5, 255.255.255.255. Here you can see label is 302. So this is 302 and this is 201. Inner label, top label. Okay, so label and forwarding, rest forwarding will be same on router number 4, router number 1, 2 and 3, right? When router 3 will receive it, router 3 will forward it to router number 5, and only router 5 is going to check IPv6 header, IPv6 header or ICMP version 6 message, right? These devices are going to forward traffic on the basis of, like, this provider routers are going to forward traffic on the basis of label only, and router number 1 and router number 3 will add and pop remove the label according to prefixes, according to IPv4 prefixes. So this is how we can configure IPv6 over MPLS, how we can configure IPv6 over MPLS. Hope this video was helpful for you. If you have learned something from this video, guys, please hit on like button. We will meet in next video. Till then, stay safe. Bye bye. That's all for today. Thanks for watching.